Okay, so good afternoon. I'm Cassandra Atkins. No, Erik Engeberg. I am from the Ocean and Mechanical Engineering Department, and I work in robotics. A lot of the stuff I do is in biomedical robotics. And by the way, I forgot my personal introduction. See, I'm really following along with the stuff. But anyway, I like most kind of sports, snowboarding. We do that a lot in Florida. Scuba diving sometimes, spearfishing. I like fresh seafood. I like mountains, so my vacations are not in Florida. And trying to do kiteboarding, trying to learn kiteboarding. It's a new challenge for me, and that's kind of my new thing. I really suck at it still. So mainly it's just like a disheveled man getting dragged really rapidly through charging waves with jellyfish everywhere. You'll see what I mean. So a lot of the stuff I do is in biomedical robotics, and the stuff is largely focused on prosthetics and how you can help people recover a sensation of touch or motor control after they've lost a limb. So if your arm gets blown off or chopped off, or if you're born without a hand, how we can help solve problems that those kind of people have. So I do have quite a few videos, and I'm just going to play them in the background, and then I'll talk about them as they're playing. Okay, so here's one where a problem that amputees have is that they can't really control multiple degrees of freedom at the same time. So they can't do two things at once. Like you grab the keys, open the door, and you got some groceries in your other fingers of your hand. You're doing multitasking all the time. Cannot do that. So I found a new way of signal processing muscle signals to make it so you can do two things at the same time. That's me, same shirt. It's proving it's me, same shirt. That's me, that's my shirt. And so yeah, here we did a novel technique to do two things at once. And so we published this a while back, and that was kind of the foundation for one of the grants I've got right now for multitasking. Here's another one we did, which I think would be really great to, oh, not this one, spoiler. Here's one we did with robotic eye-hand coordination. And so I think this would be great to try and teach random thought, autistic children or autistic babies how to learn from a robotic pedagogue that could perhaps be teaching children with some kind of learning disorder, perhaps. I'm sure that speaks to no one in this room. I'm sure no one knows what I'm talking about, Jackie. So here's one. Okay, so what we're looking at here is how we can communicate information from a robot to a person, and we're looking at an eye-hand coordination strategy. So this is actually the face of the person who programmed it. So we 3D scanned her face, just like a Terminator, and put her onto a robot, and she programmed it. That's her face. That's exactly who programmed it. So that's pretty impressive. Stephanie, she's a great student. She's now working for Lockheed Martin, so go Stephanie. All right, let's see, we got, okay, here's another one showing robot-robot interaction. So basically what we're doing is technical demonstration. So we've got this dexterous robot. This has 20 motors. This has 6 motors in the arm. So how you can synchronize 26 motors to do something intelligent is quite interesting and challenging. But beyond that, what we've also programmed is a way for this robot to know what that robot is feeling. Okay, and so the applications are really broad in terms of teams of robots that are performing any task. Think of grocery stores, warehouses, any kind of place where multiple things have to do a lot of work. So this one knows that this one's got the cup because this one knows what that one's feeling through the network connection. All right, and so now this one's going to go grab it, and then when this one detects that it's the cup is being taken out of the hand, it's going to open as it detects that upward motion and release the cup into the other robot hand. So that's another cool thing that we got, and applications could certainly be for amputees, prosthetics. So how would a person, not have to think all the time cognitively burdened with the tasks of low-level menial operations we take for granted? So you see my hand motions, they're really just all over the place. Okay, people who have lost a limb and they have a replacement prosthetic limb, they can't do that. All right, so how you can automate this or make it more natural is actually something that's very useful and powerful for a person who can recover from a traumatic loss of a limb in a meaningful way. So I'm going to have a rough segue transition now into my other area of interest, which I told you I like to scuba dive, and I also like the ocean. So what I did with Jen Frame, she's the builder of the Jennyfish. Her name is Jennifer. So she built the Jennyfish. Here's our 2-minute highlight or 1-minute highlight video. You can see it swimming sideways. So this is with soft robotic technology. Basically, these are like controllable balloons, really smart balloons that are being controlled by a pump that is inflating them with water so that you can direct the motion. And the application is for coral reef health monitoring. As you may or may not be aware, I hope you are aware that the reefs are in danger right now all over the world. Okay? So this is one way that we can monitor the health of reefs without damaging them. Hopefully you know that coral is very fragile, and so if you have a boat in there that's monitoring them, you can chop them to bits with a propeller, or the hull can crash into it and break the coral in half. This guy is really squishy, and so it's not going to do that. And it's also very low energy, so it's got you can think about it as a very high gas mileage rate. So jellyfish in nature are renowned for highly efficient locomotion, so that they can travel from A to B with extremely low energy expenditure. Here's one where we got a video. They were taking the video in the wrong orientation, but so we're showing how it can squeeze through these narrow orifices. So these like circular holes are smaller than the jellyfish's nominal diameter. So it's actually able to swim through these holes without actually getting caught. And so this is our first version of the jellyfish, which we've upgraded in the last year or two. So this is probably like 3-4 years ago we were doing this. We've got some new ones that are pretty sweet. I'm just going to randomly pick videos from my GoPro. And okay, so here's a night dive we did. So the new one we made, oh man, it looks so much better on the computer screen. So what it actually looks like is something like that, and it glows in the dark. It's pretty cool. So this, and it looks, I have the same thing with my projector at home. Watching videos in the daytime is not really something that works well, but it's pretty nice. I know, it's too big. I can make the screen smaller if you want. I know. So that's one of them. Then that was when we were doing the reef cleanup. So we went into underneath the Deerfield Pier, and we're just cleaning up all the garbage underneath that pier. And there was like tons and tons of garbage under one little small pier. And that's just one little pier right next to the shore. Think about how much is in the ocean everywhere else. So anyway, here's where we were doing a drift dive just a couple miles off the coast here, just right off the coast of Boca Raton. And the cameraman has such steady hands. I'm just, anyway, pat on the back. But anyway, I'm just kidding. So this is like, you can't even see the reef. That's a shame. But what we're testing is an adaptive controller. So we're testing the depth control. And so basically what we want is to modulate the frequency of actuation to have a smooth depth profile as it's swimming along the reef. So this is maintaining a constant depth underneath the surface of the water based on the frequency of actuation. So we did some lab tests to see what is the correlation between thrust force and frequency of actuation, put that into an adaptive controller, and so that's what that thing's doing right now. So right now in that one it's only sensing depth, and here we do have ability to sense temperature and light, and we can put whatever sensors on it we want. This is in Key Largo, the Coral Restoration Foundation. So they grow coral on these coral trees. And then basically what the idea is that, we go there, we pick the coral off the tree, and then we explant it onto a reef that's just about dead. And then with some epoxy, you actually glue these onto the reef. And then over the years, they grow back. And I actually saw it. I did it myself. I saw some sites that the organization had been working on for several years, and these are nearly extinct in Florida, but they're actually basically replanting them into the reef, and hopefully they'll survive and replenish the reefs someday.
So the jellyfish doesn't have a camera on it, or what's the output? I know you said.
Well, at this stage, we're just trying to do control of it, and so.
What are you planning on putting on it?
Oh, I'd love to have a camera, like you're saying. I would love to have a salinity sensor to test for salt content. Can also check for different kind of contaminants or pollutants. So, for example, one of the
You could use that for the microplastic, right?
yeah, for exactly, and or to detect for any kind of pathogens or viruses that are going to infect the coral reef, you know. So that's definitely something that could be of interest. So that's when we did the Coral Restoration Foundation. We got this one. Okay, yeah, here we did a swim through to show that, like in the reef itself, the jellyfish can actually swim through, and so this one's pretty nice. So there's like a small hole in the coral wall, and it's swimming up and out through there, and pretty fun project. That's that one. I think I got one more. Okay, yeah, here's like another reef dive. And this is just right off the coast here. It's just a beautiful reef we have, which is, you know, nice. So this is where I get all my dinner. I usually get dinner here. This is kind of like the grocery store for me, except, you know, with a spear gun and a lobster snare. So I know it sounds a little weird that, you know, I'm trying to save the reefs, but then I go out there and kill fish. Help me with the ethics of this. We've got a criminal justice. Is this like some kind of ethical gray area? Yeah, I think so. But no, but the reality is that it's, you know, it's all within the regulations of Florida, and so the main thing is anything you take out of the ocean, you eat it. Okay? That's the thing. You don't take anything out of the ocean and then throw it away. I think if you do that, it's for me, I can justify it. Yeah. Anyway, so that's me. That's just a couple videos, some of the greatest of. Oh, got one more. Anyway, it's fine. Any questions? I'm happy to answer. Other than that,
Is it self-navigating?
yeah. So this is fully autonomous, but you know, it is like real jellyfish. It is quite at the mercy of the current. So the idea is that it's going to do drift dives. So you put it in, and then it has nominal maneuverability within the current, and then. Yeah, so it can, you know, it's definitely going to be at the mercy of the elements, but it can maneuver somewhat. Yeah.
What's its power source?
All right, on that one we have some LiPo batteries. Batteries, yeah. Yeah.
What sensors do you use on it? Because I know you said you don't have a camera on it currently.
Right now we don't. Right now it's a depth sensor to maintain the depth. We've got an optical sensor, which we haven't really used much, but the idea is to relate the optical sensor to like the amount of plankton that's in the water or some biological element. And then we also have the temperature sensor to monitor temperature. But like I said, space is at a premium when you're jellyfish like this. And so those are the three we chose. We could put whatever we want if we want to make it bigger. Yeah. Okay, thank you.